What if Tesla's Optimus Gen 3 is not just learning how to work, but quietly learning how to build the next generation of itself? That sounds like science fiction. But inside Tesla's factories, something unusual is happening. For years, Tesla was known as an electric car company, Model S, Model X, Model 3, Model Y, cars that changed the entire auto industry. But now, the most important product inside Tesla may not have wheels at all. It may have arms, legs, hands, cameras, neural networks, and one question is starting to matter more than any other. Is Tesla Optimus Gen 3 simply learning? Or is it the beginning of something much bigger? For most people, a humanoid robot is still a demo on stage. It waves, it walks slowly, it picks up objects.
It looks impressive for 30 seconds, and then the video ends.
But Tesla is not trying to build a robot for a stage. Tesla is trying to build a robot for a factory. That difference changes everything.
A stage demo can be controlled. The lighting is perfect. The floor is clean. The task is rehearsed. But a factory is different.
A factory is chaos with rules. Parts move, humans walk by, tools are misplaced, boxes are heavy, surfaces are uneven, mistakes are expensive. And this is exactly where Optimus becomes interesting. Every time Optimus fails, it creates data.
A wrong grip angle, a delayed movement, too much pressure from one finger, a hesitation before picking up a part, a balance correction after a step.
To a normal person, that is failure. To Tesla, that is training data. And this is where the story becomes more important than the robot itself.
Tesla already understands how to use real-world data. Its self-driving system was not built only in a lab. It learned from millions of vehicles, millions of miles, and countless edge cases from the real world.
Now Tesla may be applying the same logic to humanoid robots. Cars taught Tesla how to see the road.
Factories may teach Optimus how to understand the physical world. But here is the interesting part.
If Optimus Gen 3 is collecting real-world factory data every single day, then Gen 3 may not be the final product.
It may be the teacher. The real product may be Gen 4. Think about that. A robot enters the factory. It performs simple tasks.
It makes mistakes. It records those mistakes. Tesla improves the model. The next version becomes better. Then that version collects even more data.
Robot. Data. Training. Better robot. Again and again. That is not just manufacturing. That is a learning loop. And if Tesla can make that loop work, the advantage becomes extremely difficult to copy. Competitors can raise money. They can hire engineers. They can build prototypes. But can they place thousands of robots inside their own factories and let them learn from real production work? That is the real question.
This is why Optimus Gen 3 matters. Not because it can walk, not because it can wave,
not because it looks human. It matters because it may be the first serious step toward physical AI at industrial scale. AI that does not just answer questions. AI that moves through the world. AI that touches objects. AI that learns from weight, friction, balance, force, and failure. And that is a completely different game. But there is still one problem Tesla cannot escape. Are these robots truly doing meaningful work?
Or are they still mostly collecting data? Because if Optimus is only learning, Tesla is still early.
But if Optimus is already useful, even in a limited way, then the robotics race may have entered a new phase. A phase where AI is no longer trapped inside a screen. It has a body, it has a workplace, and it has a reason to improve every single day. So maybe the real question is not whether Optimus Gen 3 is learning or dominating. Maybe the real question is this:
at what point does learning become dominance? Drop your thoughts in the comments.
Is Tesla building the future of robotic, or are we still watching the early training phase of a much bigger machine?